Inverse ratio rules. Inverse ratio rules. So go ahead and first copy that statement down. If the sine of A, let me get a pen going here, comma. If the sine of A is equal to A over B, comma, then the inverse sine, again, sine the negative 1 power, that means inverse sine. But right, inverse sine. Whenever you see that negative 1, then the inverse sine of A over B is the measure of angle A. I'm going to copy that down. I want to write nice and clear because you'll be able to use this on assignments, tests, and quizzes. You're not turning this into me, this is for you. All right, how about the second statement? If the cosine of A is A over B, then the inverse cosine of A over B is the measure of angle A. And the last one, if the tangent of A, again, A refers to an angle here on these statements, these three statements. If the tangent of angle A is A over B, then the inverse tangent of A over B is a measure of angle A. I'm going to copy that down. So we're going to solve for angle R and T here in example 1. I'm going to write this down. Here we go. So this example is different than the other example that I've been giving you up to this point, in that I'm not asking you to solve for a side. Right now, I'm not asking you to solve for this side. If I ask you to solve for this side, you can use Pythagorean theorem. Could you use trigonometry to solve that third side? Sine, cosine, or tangent? How come? Give me an argument. Right. I need the angle measures. In order to use trigonometry like we've been doing, you need to know the degrees of R or the other acute angle, T, which we don't know. But the beautiful thing is trigonometry is going to help us find those angle measures. Now, so let's find angle R first. Okay? Let's find angle R. The first thing we want to do is find the ratio. What sides are given in relation to angle R? I'll show up. So tangent, adjacent, and hypotenuse. Is that tangent? So look at these two sides. This side,
Yeah.
this side right here.
Oh, my bad. Cosine.
Cosine. So this side right here, this side 32, is what in relation to R? That would be the hypotenuse side, because look, it's opposite the 90. So I'm dealing with the hypotenuse, and I'm dealing with, what's this side in relation to R? The adjacent. So adjacent and hypotenuse, I'm thinking of SOHCAHTOA, what ratio has adjacent and hypotenuse in it, and I can see just by writing it out, it was a cosine. I'll stop there. Hold on, that makes sense. Yeah. This. Oh, cool. So look what I'm going to do. I'm solving for angle R, so watch this. The cosine of angle R, I'll put cosine of R, is going to equal to, ready for this? Adjacent to R is 27. Hypotenuse is 32. Okay? But we don't know what angle R is, so I'm going to use inverse trigonometry. We just wrote down the rule here. Notice this rule says if the cosine of some unknown angle is A over B, then look at the inverse cosine of A over B is equal to the measure of angle A. I'm going to use this rule here, the second one. Check it out. Look at the way I'm going to set it up. You write it with me. I'm going to write the inverse cosine, again, cosine of -1 of 27 over 32. There's the ratio. It's going to equal to the measure of angle R. There's the move. This is the inverse trigonometry move. Right there. So on your calculator, hit inverse cosine 27 over 32. Hit enter. What you guys get? 32.5. So the measure of angle R, look at this, is equal to 32.5 to the nearest tenth. Okay? Angle R, we found angle R now. This is 32.5 degrees. How do I find angle T? Any ideas of how to find angle T now? Sine. Okay. I'm thinking of an easier way. Nice. Remember we went over how all the angles of a triangle add up to 180? At this point, we can solve for angle T using the triangle sum theorem. 180 minus 90 minus this is going to give us what angle T is. So the measure of angle T would be that. But let's go ahead and use trigonometry since we're on the topic of trigonometry. Let's do what Ochoa kind of just mentioned first. Let's solve for angle T using inverse trig, since that's the lesson for today. We could have done it just with the triangle sum theorem, knowing they all add up to be 180, but that would be the easiest way. But since, again, we're on this topic of inverse trigonometry, let's find the measure of angle T. So the ratio for angle T that we'll use, we have hypotenuse here. The 32 is the hypotenuse, and the 27 is opposite. Ochoa, you mentioned the ratio. What was it? Sine. So opposite and hypotenuse is what we're dealing with. Well, that's the SO in SOHCAHTOA. So I'm going to take sine of angle T is 27 over 32. So let me rewrite it as an inverse trig equation. I'm dealing with an angle, so the inverse sine, look at that, the inverse sine, sine to the -1 power of 27 over 32 is going to equal to the measure of angle T. So let's do that one to the nearest 10. That's 27 over 32. And let me know what you guys get. The measure of angle T should approximately be, anybody? It's 7.5. 57.5 degrees. And that makes sense. If you add both of those, if you add up angle R and angle T, they equal to 90. Then you have the other 90-degree angle, they equal to 180. So it all comes out, it all works out. When I say solve the right triangle, what that means is find all angles and sides. The whole shebang. The whole enchilada. I want every side. I want every angles. I want Ms. Rom to ask her question. Would you mind after this example? Bye. Hurry. You're going to be on the video, by the way. We're recording. If I ask you to solve for angles, you use inverse trig or triangle sum theorem. If I ask you to solve for sides, you use normal trigonometry or Pythagorean theorem. That's the big idea right now. So you can solve for all the parts now of a right triangle, no matter what's given. We're at that point now. So let's go ahead and solve for one of the angles. Let's solve for angle A first. Here we go. So solve for angle A. Here we go. So I'm using I need to solve for an angle first. That means I'm going to use inverse trig here. Not normal trigonometry, but inverse trigonometry because I'm solving for an angle. Here we go. So the measure of angle A, what sides are given? Well, what side is this in relation to A? Adjacent and right here. So I got opposite and adjacent. Ochoa, what ratio involves both of those? Tangent. Think so, Katoa? Opposite and adjacent. So the tangent, here we go. The tangent of angle A, so the tangent of angle A is going to be 16 over 8. But we don't know the degrees of angle A, so we're going to use inverse trig. That means the inverse tangent of angle A, actually of the ratio now, will give us the angle. Will give us the measure of angle A. Notice. So on your calculator, hit inverse tangent, 16 divided by 8. And run the nearest tenth. Anybody? 63.4. Ochoa, did you get that? Degrees. Colon, did you get that? What practices this statement?
No.
All right, so that's the measure of angle A. What's the mission, though? The mission here is to solve the right triangle. That means find all the angles and sides. So we know angle A is 63.4. Is there any other angles I have to solve for? B. I can use inverse trig, or I can just use triangle sum theorem. I'm going to use triangle sum theorem. The measure of angle B is equal to 180 minus 90, that's the right angle, minus 63.4. Would someone please do it on the calculator? Because I don't have the calculator. What's 180 minus 90 minus 63.4? 26.6. So the measure of angle B is equal to 26.6 degrees. Cool. 26.6 degrees. Are we done yet? What do we got left, Ochoa? Not partners, and we're done with the mission. We solve for every angle and every side. We have decisions to make. Look at the second star up here. To solve for sides, you can use normal trig ratio like we have been doing for the past couple of days, or you can use Pythagorean theorem. It's up to you. Whatever you feel more comfortable with. I like trigonometry myself. But since we've been doing trigonometry for so long already, I'm going to go back to some Pythagorean theorem just for the sheer fun of it. Okay? So Pythagorean theorem says, I'll use a green marker to solve for the side here. So I'm going to solve for side AB. What I'll do is I'll just label it X. And we learned 2 weeks ago in the Pythagorean theorem that A squared plus B squared is C squared. And C is always what side in the circle load? Your C is always what? Starts with an H? Nice. So in this case, the hypotenuse is x, so I'm going to replace C with x squared. I got B is 16. A is 8. Moving right along. 8 squared is going to be 64. 16 squared, can someone do that for me? What's 16 to the second power? 256, making this parentheses, equals x squared. 256 plus 64. And now we'll square root both sides, right, to get x alone. X then is approximately to the nearest tenth, the square root of 320. Help. Yeah? 0.9? So x is approximately 17.9. We've solved our right triangle. We've solved for all the parts.